I'd like it to take a look at an example from section 2.4 with you to understand infinite limits. This is an example where we're looking at a polynomial over a polynomial, so a rational function, and we're evaluating the limit, in this case, as we approach 3 from either the right or the left, and then in part C here, we look at the two-sided limit. Okay, and I want to go through and suggest a way of thinking about this that I think will help when you see similar examples. Let's think about what's happening to the numerator and denominator of that expression as z approaches 3 from the right. Well, the numerator of that expression is going to approach a constant, because as z approaches 3 from either direction, z minus 1 is approaching 2, z minus 2 is approaching 1. So I could look at that numerator and say that that's approaching 2 times 1, which is 2. Now let's think about the denominator, because that's where the challenge comes in here. The denominator of that expression is approaching 0. Okay, and that's the reason why we can't simply plug in 3 and get an answer. Okay. But as we approach 3 from the right, that means that the z here, we can think of as going through values like 4, 3.5, 3.1, 3.01, 3.001. So values that are to the right of 3. So if you have something a little bit bigger than 3 minus 3, that's going to remain positive as it approaches 0. So here's how I like to denote that, and I think you're going to find this is a way of helping to understand what kind of infinite limit you're getting. I'm going to denote that with a 0 with a plus superscript. And what that's indicating is that the denominator is approaching 0, but it's approaching 0 through positive values. And here's why that's important. As we have a numerator that's approaching a finite non-zero limit, and the denominator that's approaching 0 through positive values, this fraction is going to remain positive for all these values of z that are to the right of 3. Okay, so that means that this expression, this non-zero over 0, when they're positive, positive, that means that whole thing is going to approach positive infinity. Because a positive divided by a positive is still positive. And I encourage you to maybe try some specific values for z. Try 3.1, try 3.01, try 3.001. That's going to help kind of build your intuition about why it's working the way that it is. Now let's compare that to what we get as we approach from the left. Okay. Now as we approach from the left, the numerator, okay, we still have values that are approaching 3. So the numerator is still approaching 2 times 1, or 2. So that part does not change. The denominator is approaching 0, but this time we're coming from the opposite direction. We're coming from the left. So if we plug in 2.9, 2.99, 2.999, this is approaching 0, but it's approaching 0 through negative values. So we'll denote that with a 0 with a negative sign as a superscript. Okay. Copy that over there. And now we have a positive non-zero quantity over something that's approaching 0 through negative values. So that fraction, we've got positive over negative, that's going to be growing larger and larger values without bound, but negative ones. Okay, so larger and larger in magnitude. In other words, that limit is negative infinity. Okay, so it's all about looking at the signs of the numerator and denominator. And when you've got a non-zero finite limit in the top and a 0 limit in the denominator, then the signs are going to tell you whether you're approaching positive infinity or negative infinity. Now, when we look at this part C, which is asking for the two-sided limit, well, same thing we saw earlier in chapter 2. If the one-sided limits are different, we always say that the two-sided limit does not exist. All right, so what I want to do is just draw a rough graph. Now, you don't need to graph whatsoever to do this kind of problem, but the only reason I want to add a graph to this video is simply to help make sense about what are we actually seeing happening, and what do we understand about these infinite limits in terms of graphs. Okay, so this is going to be a rough graph. Don't expect perfection here, but the infinite limits we're seeing at 3 correspond to a vertical asymptote. And we've got a vertical asymptote where on one side we are approaching positive infinity, and the other side we're approaching negative infinity. Let's see. So we're going to have something that is very roughly something like this. Okay. Now, don't worry too much about the shape other than what's going on at the as it approaches that asymptote. On this side, the limit is negative infinity, and I'm just using some information about the intercepts to kind of fine-tune that graph. This one, the discussion about horizontal asymptotes, which this does not have, gets into the next section, and I'm not going to focus on that here. But again, the main thing I want you to take away from this graph is just seeing that on one side we're going upwards as we approach that asymptote, on the other side we're going downwards as we approach that asymptote. And that's what we saw in parts A and B. Thank you. I'll see you in the next video.